Let's show how supersymmetry is a required feature of string theory to keep it consistent. So it's all about this central charge. And see, we have two oscillations, one going left and one going right, okay? And both of these oscillations have to essentially create a charge, and then it cancels with a ghost such that the charge is zero. Now, in electromagnetism, anything that, like an electron going around a loop like this, will generate a little charge, and so that's why we have quantized charge in electromagnetism. So the same thing happens with strings in supersymmetry. So bosons have a charge of 1, and then fermions have a charge of 1/2. So this is some pretty normal stuff. And then we have sort of two different types of supersymmetry. Now, one of them is going to be the idea that we can send 10-dimensional boson and fermion oscillations on both sides. So on the left side, we're going to send a 10-dimensional bosonic and 10-dimensional fermionic oscillation. And then the symmetry is that on the right side, we send the same amount. So another 10-dimensional bosonic and a 10-dimensional fermionic oscillation. So they just go one left and one right. And so what happens is that we get something like a charge on the left side that equals 10 plus 5, because we have 10 from the bosons and then 5 from the fermions. So we get left equaling the right side, so we get 15 on both sides. And that means that the ghost on both sides is also negative 15. So this whole idea is that we're sending these 10-dimensional things, a pair of them on the left side, and then also on the right side. And then what happens is we cancel everything to 0. And so we get consistency in type 1 or type 2 string theory models. Now, there's another type of model, which is the heterotic version, where, try to zoom out here a little bit, where we have 26 dimensions that go onto the left side, right here. It's a little bit unbalanced here. A 26-dimensional bosonic oscillation on the left side, which is made up of 10 spacetime and 16 internal dimensions. So that we still have a 10-dimensional thing on the left. And on the right side, we go ahead and send a 10-dimensional boson and a 10-dimensional fermionic. This is called a superstring. So this is a superstring that contains both of them. And we'll go ahead and send this to the right side. So on the right side, we get the usual 10 plus 5, which gives us negative 15. And on the left side, we get this negative 26, or this 26th-dimensional field. And that's 10 space-time and 10 internal. And so this is the difference between the heterotic string theories and the type 1 or type 2 string theories. It's basically just what kind of supersymmetry are we enforcing? Is it 10, 10 on the left and 10, 10 on the right? Or is it 26 on the left and 10, 10, 10 really on the right? So this is how we can start to enforce supersymmetry